this video, we're going to find the unknown side of a triangle that's part of a larger non-right-angled triangle, or when that's divided up, it makes two smaller right-angled triangles. We're going to find this side here, the x side. Now, in order to find an unknown side of a triangle, we need to know two other sides of that triangle. We know the 15, but we don't know the other side of that triangle. Fortunately, we can find that by using the other right-angled triangle, this one here, because we know the 18 centimeters and we know the 9 centimeters. So let's call this unknown side here y. If we label our triangle for Pythagoras, C is the hypotenuse, A and B are both shorter sides. So we're trying to find the A side. We use the version of the formula A squared is C squared minus B squared. Our A value is y. Our C value is 18 squared minus 9 squared. So we have y squared equals 324 minus 9 squared is 81. Y squared is equal to 243. So to find y, we take the square root of both sides and we're left with y equals the square root of 243. Now we could evaluate that and get a decimal approximation, but if we do that, we're going to end up carrying through a tiny little rounding off error, and our final result won't be as accurate as it otherwise would. So we want to leave that as what we call a surd, leave it as square root 243. That preserves the exact value and doesn't round off at all. For final answers, we don't want to give our answers like this. We want to give an approximation, but in this case, while we're going to use that value again, we're going to keep its exact value. So we now know the length of that side. That side is square root 243. So we can change that on our diagram, square root 243. And now we know two sides of the triangle and we can find that x value. We know 15, we know square root 243. So once again, we label for the Pythagorean theorem. We have C, A, maybe we'll call that side B, so that we can keep our A as this side here. C, B, and A. We're finding C this time, so we're going to use the Pythagorean theorem rearranged as C squared is A squared plus B squared. And we sub in our values. Our A is square root 243 squared plus our B is 15 squared. And so the square root and the square, they actually cancel each other, and that pops out as 243 plus 15 squared is 225. And so we end up with x squared equals 468. And to find x, we take the square root of both sides. And now, because we're at our final answer, we do want to round off. We don't need that exact answer anymore. We can do a decimal approximation, and that is 21.63 centimeters. So the x side here is 21.63 centimeters. We had to use the Pythagorean theorem twice here. We kept that exact value as a surd and carried it through, and then rounded off at the very end.